Good morning, students. How are you all? So here today I am going to explain that topic, chapter number 9, sound, class 8 standard, right? That is NCERT, that is only. So the sound chapter we will study this topic. So today here, so what do you mean by sound? We will get many sounds here. We will hear, right? So surrounding us, right? So here, what do you mean by sound? Sound is a form of energy. Sound is a form of energy that produces sensation of hearing. Sound is a form of energy that produces sensation of energy and a sensation of hearing. Understood? So there we will study in that sound so many things, and we will study the different types of sound that we will hear. What? If you are staying in home, if no one are there, then you see, then if you have wall clock, then the wall clock needles will rotate in the clockwise direction. Then you see that ticking of clock sound, tick 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 tick. If no one is there, if there is no other sound, then we can hear the sound of ticking of clock. Right? And if no one are there in home also, then also we will hear that sound, humming of mosquitoes. Like sound as like that sound will come the mosquitoes. So even in near the home, opposite of the home, on the roads of the home, near the home, if the night time is there, when you are going to sleep, that time you can see the barking of dogs outside. Oh, we can hear the sound, but everything is silent, but the dogs are barking. So that also we will get the sound, we will sensation of hearing. And sometimes we will see near the park is there, the children are playing, that also we will get the sound, right? And if you go in the roads on there, many vehicles will move on the road, we will get different types of horns, right? Like that, so many things, so many sounds, so many horns we will get sound. One is small, that is pitch sound, and louder sound. Like that we will get all the types of sound on the roads, right? So what is a sound? Sound is a form of energy. Sound is a kind of wave also. Wave, how? The wave will transpose the sound from, we will hear when someone is blow the horn, and we will get the sound. The sound will comes in a wave motion, in a wave, like that it will come. What is a wave? Wave, it is a periodic disturbance in a medium that transfers energy from one particle to another particle. Understood? So we will get the sound, that is for the wave will transpose in a periodic motion. Periodic means in continuously the motion will move from one direction to another. It is in a medium that transfers energy from one particle to another particle. What do you mean by periodic? Periodic means regular interval of time. Right? Okay. Now, next one, types of waves. Wow, there are two types of waves. One is mechanical wave and another one is electromagnetic wave. One is mechanical wave and another one is that is for electromagnetic waves, right? What is mechanical wave? It is that which needs medium to travel. Any object, that is for mechanical wave, means that if clicking of blowing of horn, one that is in medium. It is in medium to travel. And electromagnetic waves, which can travel through medium as well as in vacuum. If you take, for example, if the for the phone cables are there, if you call from one person to another person, the sound will go through wire, right? Through wire, that is in vacuum. If there is no air, something is there, then the sound will transfer from one medium to another medium. That is nothing but electromagnetic waves. Understood? Understood that one? Okay. Then types of waves depending upon how the particles moves. Types of waves, that is depending upon how the particles move. There are two types of waves there. That is, for first one is longitudinal wave and another one is transverse wave. What do you mean by longitudinal waves? It is the longitudinal wave is that in which particle vibrate from to and fro. To and fro means some particle stop here. This side, some particles will move in another direction. Understood? Some particle will move in one direction and another particle will move in, some particles will move in different direction. This is in the rest position. Some particles will move in this direction and some particles will move in this direction. This is to and fro. This is to and fro. These will go in this direction, this will go in this direction. This is nothing but, that is for longitudinal wave. Understood? Longitudinal wave also consists of compression and rarefaction. Compression and rarefaction. Compression means it will come to close. The particles will come to close. Particles will come into close. That is compression. And rarefaction means it will go so far. It will go, the particles will go so far. Understood? It will make a distance. It will move. That is for, so compression means it is a region which particles are closer to each other. It will come to closer each other. That is nothing but compression. And the rarefaction is the particles in the region which particle will are far from each other. It will make a distance of that. It will move. That is for so far. Understood? That is for in the longitudinal wave. These are consist of two, crest and trough. Understood? Next I am going to explain, that is transverse wave. Transverse wave is that in which particles vibrate up. Particles are vibrating up. Particles are vibrate up. And in the transverse wave, that is also having, they are consist of crest and trough. Crest and trough means it will go up and down. It will go in up and this is up, this is down, this is up and down. Like that it will go. That is crest and crest, that is up, elevation means it will go up, and that is depression, that is down, that is trough. That is trough. Understood my point? Okay, this is for transverse wave consisting of crest and trough. Crest is having, it will go in the lift up upward direction, and trough means it will go in the depression in wave, that is downward direction. Got understood? Next one is I am going to explain, that is oscillation. What do you mean by oscillation? Oscillation means it is the complete movement of particles about its mean position, as well as you can take wall clock also you can take. It will move from direction to here, or you take this is one stand, you take this, and here one stand, this pole is there. We have, this is the thread, this is iron ball. If you pull and leave, it will moving here and there. From the rest position to this direction, this will go in this direction. Again from the rest position, again it will come this direction. So this is the stand, this is the stand, only stand. Or you can take, that is for oscillation will go up and down also. Oscillation will go, this is the rest position, or you can take, this is the side position, this is arrow marks. That is also we can take. It is a complete movement. From this direction will go, again it will come to the mean position, again it will go in this direction. Left to right or up to down. This will take from the mean position, it will go up and down, and again it will come back to the mean position also. Right? That is nothing but oscillation. What do you mean by next one is, I am going to explain, that is amplitude. Next one is amplitude. Amplitude is the maximum displacement of particles from its mean position either direction. Amplitude means when the wave particles will move, see, up, down, that is will go. This is the main part of that. This is amplitude. This is the reason of that. Our crust and trough, it has, this is nothing but amplitude. Understood? This place is where measure, that is for amplitude. The distance here from that mean position to here, that is amplitude. Here also amplitude will be there. Amplitude, amplitude, amplitude. Understood? The maximum displacement of the particles, the maximum displacement of the particle, the maximum displacement of the particles from its mean position, to either direction, either upward direction, either downward direction. Understood that one? Okay. Next one is frequency. Frequency means number of sound waves produced per second. If, for example, if you take this from, we will take here, this is upward direction and downward direction. This one complete, that is crust and trough. We are taking, that is complete one, that the distance is, we are taking the, how much time it was taken, that is for how much number of sounds it will come. This is first 1, that is again, this is 2, this is from here to here, that is 2, number of frequency is 2. Again if you take like that, again you take up to here, that here to here, that is 3. Like that we have to calculate that number of frequency is 3 Hertz. Number of frequency is 3 Hertz. Like that we have to calculate the number of frequency. Did you got understood? Okay. Next one is, I am going to explain, that is for time period. Next I am going to explain is, that is for time period. Time period means from here to here it will travel crust and trough, though how long it will take. The distance between the two consecutive, the time taken to complete one oscillation, that is one oscillation. This is one oscillation which is taken, how long it was taken, that time we have to calculate in seconds. Understood? Next one is, I am going to explain, that is for wavelength. This is the crust and trough will be there. The distance between that is lambda, that is wavelength lambda. The distance between that, say, the distance between the two consecutive crust and trough, that we are taken. Here also we can calculate here to here, what is the distance will be there, that we can calculate. The symbol of wavelength is lambda. Understood my point? Okay. Next one, I would like to explain velocity of wave, the sound wave, the speed of with which sound travels per meter second. What is the velocity we will taking in a meter per second? How many meters which has traveled the velocity, and the velocity will be there. The wave travels from one medium to another medium, and how long it was taken, what is the speed, how many meters covered, and how many time has taken, that is in seconds. That is for meter per second. Up to here I taught here. The next I will explain you. I will revise you in the part 1, repeating once again. See here, what we have studied in this chapter, in this starting position. So, sound is a form of energy, and that sound produce and sensation of hearing. There are different types of sound that we hear. Ticking of clock, hemming of mosquitoes, barking of dog, children playing, a horn outside on the road, and also sound is a kind of wave. I told you a wave is a periodic motion disturbance with a medium that transfers energy from one particle to another particle. What do you mean by period? Period means regular interval of time. Understood? Then there are the two types of waves. One is mechanical wave, and that is electromagnetic waves. Sound wave, that is for, and lightning also it is also electromagnetic waves. Right? So I told you mechanical wave, it is that which needs medium to travel. Electromagnetic wave which can travel through medium as well as vacuum also. Already I given some without any water is there, no air is there, something is there like that. So any no object will be there. Then we call it as, we will say that is for electromagnetic wave we can apply here. And even that types of wave depending upon the particles, that is for longitudinal wave and transverse wave. First one is longitudinal wave. It is that in which particles vibrate to and fro, and longitudinal wave consists of compression and rarefaction. Compression means the particles will come to close, and rarefaction means it will go so far. It is so far. Next, I told you that one is transverse wave. Transverse wave in which particles vibrate up and down. If you touch on that, it will vibrate the desk. Even that makes as a sound. The particles of the vibrate. If you take water also, in the water that pond is there. If you throw one stone, it will go in a medium. The circular rings will come. This is the water. If you throw one stone here in the stone, and this will go in direction. The wave will move in this direction because it is in a medium of that. It will move in medium only in 1 to here disturbance of time that we are getting into that waves, number of waves. It will expand only. Understood? And in the transverse wave, crest and trough will come. I told you that is for elevation angle. This wave that will go up, and depression, that is trough, that will go in down, that is depression in wave. And in the oscillation, I told it is a complete moving of particles. It is mean position. Just you take as a wall clock, then that pendulum is there, the bob will be there, the pendulum will go in both direction, left and right, it will go. Right? That is nothing but oscillation, the complete oscillation. From here, it will go, the pendulum will go in this direction, again it will come in the mean position, again it will go in this direction. So, this is the wall clock will be there, and that is the pendulum is there, that is ring, that is a round one way. It will go in this direction, again it will come in the mean position, again it will go in this direction. That is nothing but oscillation. Amplitude also I told, and this is the maximum displacement of the up and down also. What is the displacement of the wave will go up and down also. What is the displacement will be there. That also we will calculate. That is one amplitude. And frequency I told, even that number of sound produced per second in hertz. And time taken, how long it was taken from traveled from one medium to another medium. So how much time it was taken for one oscillation to complete one oscillation. And the wavelength is the distance between the trough or maybe trough or crest. So what it may be, that we have taken the crest value or trough also. The distance between the two values, that is the symbol of that lambda, that is of wavelength. Understood? So next part I will explain so many things in that. So everything I will explain in that in the next part, next video. Okay. Thank you for watching.